Hello, everyone. I'm Giovanni, and I'm the Chief Product Officer at a company called Exane. Today, I'm going to be talking about the current challenges in embedded security and how we leverage eBPF and Rust inside our open source project Pulsar to make the IoT a more secure place. So, what is going on with IoT security and why is it important? The number of connected devices has been growing fast during the last few years. This opens up a very large attack surface on our daily lives, with embedded devices being deployed anywhere from critical infrastructure to automotive systems and industrial plants. The widespread of billions of affordable connected devices also comes with a big problem. When a new vulnerability is exploited on a single device, it takes very little effort to own the millions of copies of that same device that are deployed on the field. We have seen this time and time again over the last few years with the increasing incidence of IoT botnets such as Mirai. Adding to this, manufacturers have also tried to bring devices costs as low as possible, often at the expense of overall firmware quality and security. Traditional tools based on LSMs like Linux and AppArmor have not helped a lot either. They are rather complicated, not very flexible in what they can provide, and even worse, they're hard to deploy, requiring that you recompile the whole kernel every time you need to update them. For these reasons, it's not really a surprise that they are among the most disabled features by sysadmins. So what can we do to create a safer IoT landscape? eBPF is the perfect tool to obtain deep visibility inside Linux devices thanks to its near-native performance and increased safety over kernel modules. The increased portability of BPF programs across different kernel versions is a deal-breaker feature to develop solutions that can scale to the plethora of IoT distributions out there. With granular access to each individual running process, eBPF helps us understand exactly what a device is doing at any time, and allows us to build effective security logic on top of the rich data sets that we can collect in real time. In order to make the power of a BPF as accessible as possible, we at Exane are developing Pulsar. Exane Pulsar is an event-based security observability framework designed for embedded Linux devices and built in Rust. At its core, Pulsar is made up of modules that make use of eBPF to collect information about application behavior from the kernel and transform this information into events. Every event is then validated by the built-in rules engine that lets you define the behavior you want to identify as a threat. With Pulsar, you can easily monitor in real time the activity related to processes lifecycle, networking, and file system operations. And its modular architecture makes it very easy to extend, customize, and maintain the separate Pulsar modules. This separation of concerns also ensures that the whole application is resilient in the event of failure of a single module, and that you can decide the amount of information you want to keep track of without causing excessive overhead to the host machine. Pulsar supports the most common architectures found in modern IoT devices, including x86, ARM64, and RISC-V. One of the advantages of Pulsar is that it is written in Rust. Rust is a modern programming language, particularly suitable for low-level applications. With Rust, you can combine all the new features of modern languages without having to give up on low-level access to the host resources and excellent performance. Memory-related bugs in C and C++ systems often result in CVEs and emergency patches. Rust was designed to remove most of these software development security concerns at their root, especially the ones related to memory and concurrency. The Rust eBPF ecosystem is also growing a lot with exciting projects such as Aya and BPF Linker. This makes Rust the perfect programming language for developing eBPF-powered security-critical applications running inside constrained embedded systems. Thank you, and if you like the project, check out Pulsar on GitHub.